Hello students, how are you? I hope all of you are well along with your families. Children, today's video we shall be focusing on optical instruments and I hope the topic is going to be finished, right? So children, in continuation, last video we were doing compound microscope. Children, what is called a microscope? By the definition of microscope, microscope is something, some instrument which is basically used to magnify the small things into large things. So we have seen what is called the compound microscope. Children, in compound microscope, we have to use two convex lenses. Two cases I am going to discuss. Case number one, where final image is at D. D means the minimum distance of distinct vision and its value is 25 centimeters. Children, in compound microscope, we are supposed to use two convex lenses. Lens number one is called object lens, which is small in all respects. See the pattern of image formation. This is the principal focus, say FO. You keep an object over here, a ray will go in this manner. Another one will go through optical center, they will cut here at this point, so the image is formed at this point. Children, let it be A dash, B dash, let the object be A and B. Now, children, the role of this lens is over. This will become object for eye lens, another lens which is bigger in size, bigger in all respects. I make eye lens to be here. This is the bigger one called eye lens. Now, what happens? We are going to use two elementary properties of convex lenses. Can you tell me two questions I am asking? If you keep an object between optical center and principal focus, where and what type of image is formed? The answer is the image is virtual, okay? It is direct and formed on the same side of the lens. Question number two, if you keep an object right at principal focus, what is the formation of image? What type of image is formed and what is the location of image? Answer is, it is formed at infinite, it is real and inverted. Alright, so we are using now two important properties. So let us focus on when final image is at D. Children, this lens, let it be the optical center, let its principal focus be here, FE. It is the same distance called FE. Now let us see the formation of image. A ray will go parallel, will pass in this manner, another one through optical center will go in this manner. Children, these two beams, the two rays are diverging here, they will not be meeting here in this region. If you look from here, it will appear as if this ray is coming from this point and this ray is coming from this point. This is the final image is at A double dash, B double dash. So need not to tell you, this separation is called D. So children, this is the case number one when final image is formed at infinite. Need not to tell you, this diagram is extremely important. The question can come for 2 marks in your board's examination. Another important thing is what is called magnification. Children, here is simple magnification. The formula is VO upon UO 1 plus D upon FE. That is, you can say M is equal to MO into ME. What is MO? The magnification produced by object lens. What is M is ME? The magnification produced by eye lens. So in the first step, we are supposed to prove this one, and second step is this one. This is the formula for magnification. D is the 25 centimeters, the least distance or minimum distance of distinct vision. Children, one more thing here I would like to mention. What is called the length of the microscope? The distance between the two lenses is basically called the length of the microscope. Now, a simple question, a simple thing, a special case you can say, if you keep an object very close to F, that is, if UO, this separation is called UO, if UO is equal to F, then this image, this separation is called VO, this image will be shifted and it will be very close to eye lens. So in that event, the VO will be equal to L. So for that specifications, this formula will be modified as M is equal to L upon FO 1 plus D divided by FE. This is the formula, another important formula for from the point of view of numericals. Children, as far as the simple proofs are concerned, I shall be giving you these proofs in the notes. Alright, this is our case number 1 for compound microscope. Compound microscope, right? Now, let us focus on case number 2. The case number 2 says, what happens when the final image is formed at infinite and how the image is formed. So, children, for that purpose, I need to correct the diagram. The first part of the diagram remains out to be same, only there will be a change in the second part of the diagram. Children, see here, now this is going to be the eye lens. Alright, A dash B dash will be the object for eye lens. The distance between the two lenses is so adjusted that this point becomes FE, the principal focus for eye lens. So what would happen now? As I told you short while before, now if an object is kept at principal focus, what type of image is formed? You know the answer very well. Let us see the pattern of formation of image. This is once again FE. So a ray will travel parallel, will pass through FE, another one through optical center, they will go straight and straight, they will become parallel. Will they meet in this region? No, they will not be meeting in this region. Rather, if you see from here, it will appear as if this ray is coming from here and this ray is coming from here. So the final image is formed at infinite, called like this. So this is, children, the case number 2. आपने इन दोनों केसेस को बहुत ध्यान से प्रैक्टिस करनी है. और एक बात, certain queries are coming from your side. That's from the book we are not able to find out the principle of these optical instruments. So children, answer to that problem is, whatever you see in the diagram, you just convert it into language and just write down the principle. For example, if somebody says what is the principle of compound microscope in this event, what would be the answer? Like a compound microscope is the combination of two lenses, object lens of a small size and the eye lens of large size or large aperture. So when we keep an object beyond FO, then it makes the real and inverted image at A dash B dash as shown in the diagram. This will become object for eye lens, right? And then for case number 2, I am talking about the distance between the two lenses is so adjusted that it becomes right at principal focus for eye lens. So final image is formed at infinite as shown in the diagram. So no need to cramp the principle. You can just use your own language and just write down the principle. Alright. Now let us come to another important aspect of this compound microscope. In this case, what would be the formula for the magnification? Children, first step will remain out to be same. M is equal to MO into ME. MO is the magnification for object lens, M is the magnification for eye lens. So here it will become MO into ME. MO is VO upon UO and ME becomes, if you remember, D upon FE. For the second case, when the final image is formed at infinite, the magnification is given by D upon FE. So this becomes the final formula. From my side, M is equal to VO upon UO into D upon FE. The final answer. Alright. So these are the two cases for compound microscope. Children, let us now come to next optical instrument called astronomical telescope. Astronomical telescope. So our next thing is astronomical telescope. So can you tell me telescope होती क्या है? Telescope is an instrument which is basically used to see the distant objects. Astronomical telescope is used to see the astronomical bodies. They are spherical in the shape. Final image is real and inverted. So as far as the terrestrial bodies, the celestial bodies, like for example moons, stars, they are spherical in the shape. तो spherical में उल्टा सीधा सब एक बराबर. You know very well. So let us come to first case of astronomical telescope. Case number 1 is called normal adjustment. That is when final image is formed at infinite. Children, remember most important point, This is just telescope is just reciprocal of what is called compound microscope. It is also the combination of two convex lenses. Lens number 1 called object lens is large, whereas lens number 2 I draw here, it is small, right? This is just reciprocal of whatever we have seen in compound microscope. Children, let the focal length of this lens, let it be FO, let it be FO. You know, this side which basically is used to focus the objects, astronomical bodies. The distance is supposed to be infinite. So we know very well, if an object is placed at infinite, so image is formed at principal focus. So इसका image पहले से बना के रखो. That is the image. Let it be here. Just take a ray, will go in this manner. Another ray in इस region में parallel will go here. Another one with these three beams or rays are parallel to each other. After refraction, they will pass through this point. So children, the role of this lens, object lens, is over here. Now this is basically image for A dash B dash. For object lens, it will become image for object lens. It will become object for eye lens. All right, I repeat, A dash B dash is the image for object lens, but it will become object for eye lens. So the role of eye lens begins now. Let it be our eye lens. Children, just tell me, if this point is FE also, FE means the principal focus for eye lens. So what would happen? Let us see what will happen. A ray will go parallel, will go in this manner. Another one will pass through the optical center. They will become parallel to each other. So you know these rays will not be meeting in this region. यहाँ से देखोगे ऐसा लगेगा the rays are coming from here, the rays are coming from here. So it is at infinite. So the final image is formed at infinite. This is what is called the normal adjustment. Remember, practice this diagram. This is an important question from the point of view of your board's examination. Now another thing, what is called the formula for magnification. Children, for here, for magnification, m is equal to minus FO upon FE. Remember, m is equal to FO is the focal length of object lens and FE is the focal length of eye lens. If you want to express this formula in form of power, it can be m is equal to minus PE upon PE, because the focal length is reciprocal of power or power is reciprocal of focal length, whatever be, and vice versa. Alright, remember it forever. Now children, here I would like to discuss case number 2 very fast, rapidly. Case number 2 is when final image is at D, capital D, the minimum distance of distinct vision. In this event, if you shift this object to be here, then it will become in between principal focus and optical center. So children, in this event, the final image will be created somewhere here. This case is basically not the part of our syllabus, but still you are supposed to make the diagram. The diagram I shall be giving in the notes. Alright. Finally, one other important question also I am giving you. There is telescope. These telescopes and microscopes are refracting type because the refraction takes place. Children, there is another telescope, reflecting type of telescope. You need to go through one question, just find out the answer, make the diagram from the book. What are the advantages of using reflecting type of telescope over refracting type of telescope? Alright, you just see the books. In case of any query, most welcome. I shall be sorting out all the confusions and queries. Alright, thank you very much. God bless you. Take care.